How many of you know already something about Spinnaker? Okay, not enough people. I was hoping there were a lot of folks, then I could go and attend the other talk, which sounds kind of interesting. How many of you know what a Spinnaker is? Okay, can you tell me, please? I'll stand close so that you can hear.
Some kind of deployment system by Netflix.
What Spinnaker, the nautical term? Does anybody know? It's a sail. Why do you use it? Or why would you have one on your boat?
Well, when you go down the wind.
Okay?
Yeah, down the wind only.
So down the wind only, what does it do? It helps you go fast, right? Yeah. So that's what Spinnaker's about. All right, Spinnaker's about helping you go fast. It's a continuous delivery tool, platform, and I'll talk about this just a little bit. In my talk, I'll sort of spend a little bit of time motivating the need for continuous delivery. Probably this is going to be preaching to the crowd, so I won't spend a whole lot of time on it. And then I'll introduce Spinnaker, and I hope we can get something with the demo working, because it's actually kind of cool. Thanks to our Netflix team for allowing us to partake in this work with them. All right, Spinnaker is a Netflix-conceived idea. We've worked with them for the last year on making sure that Spinnaker not only can do continuous delivery for Amazon Web Services, but also for Google Cloud Platform. Oh, and while I'm at it, if you have questions, please don't hesitate to wait to the end. Or please don't wait till the end. Ask them as we go. All right, what's the motivation? Well, for Netflix, they're pioneering microservices in the cloud. They've got lots of microservices. That means lots of deployments. Failure of any microservice means they're disrupting their user experience, right? It's not just their services. All their users don't have access to stuff. So for them, there's a critical need for safe deployments. What else do we want? Well, we want to be able to deliver software faster and more confidently, right? Why? It reduces costs, time, and risk by allowing us to make incremental updates. Why do you think Google's interested in this? Any thoughts? Nobody has money. Okay, that sounds good. Any other thoughts? Money's always good. I'm sorry? No? All right, yeah, sure, we'd love to have Netflix business, but that was not the motivation for us to work with the Netflix team, all right? We know that there are lots of folks out in the community who hesitate to adopt continuous integration, continuous delivery, because it's complicated, all right? And they also hesitate to pick a cloud provider because of fear of lock-in. So we at Google want you to have good tools that you can use to reliably deploy across clouds, across hybrid clouds, which means you get to have and keep the choice of which cloud provider you want to work with. Right? Overall, working with you guys on something like Spinnaker, we'd like to set the standard for tooling in this space. All right. Why are safe deployments difficult? All right. I guess since I don't have a demo, I can ask lots of questions. Why are safe deployments difficult? No one wants to say anything. Okay. All right. Sorry. There are lots of reasons. All right. One is the delivery process is not hermetic. That means you don't actually know what's currently deployed, right? You maybe deploy a base image to a machine somewhere, and then you run some Chef or Ansible scripts and kind of populate that image up, and sometimes it works and sometimes it doesn't, and then suddenly you've got thousands of machines you're doing this to, and each configuration is slightly different. You're not exactly sure what you're ending up with. Delivery today, for many, still involves a number of manual processes, right? That makes it kind of error-prone. We've got the dev teams who build the applications. We've got the ops teams who deploy them. And so when something goes wrong in operations, the ops teams are like, well, we don't actually know what the application's doing. We didn't build it. And so it requires intervention by people like the ops teams who didn't actually build the system, and that takes longer and is more painful. And, you know, lots of folks, we've heard a little bit this morning already about folks, you know, trying to sort of shorten their release cycles. But if they don't, right, the idea is to sort of package up, well, I've got a major feature coming out, it's, you know, 12 components all have to work together. We're going to bundle all the changes into a single release. Awesome. Now we make sure that that thing sort of works together as a bundle. The challenge is it lowers the frequency of your deployments, and there, as a result, increases deployment complexity and risk. Lastly, what I'll, on the bullets here, right, is environment resources. If you're doing testing, you want to test ideally in as close to the production environment as you can, but you often can't do that, and so you've got a little test lab set up. The test lab's got some fixed number of resources. You have to compete with everyone else who's trying to build their applications. And so there's some time lag between when your software is ready and when you actually have access to the test lab so that you can go do testing. And that's no good. And there are like tons of other reasons, including organizational and political reasons that make safe deployments difficult. All right, now continuous delivery. How many of you use Jenkins for continuous delivery today? How many of you use other tools for continuous delivery today? What do you guys use? TeamCity? Bamboo? I'm sorry? Concourse? Anything else? I'm sorry? Circle CI? So that's a CI system, right? You use that for continuous delivery as well? Okay. How's that working out for you? For small teams, it's okay? So, we're aware of a number of folks who use, Jenkins, right, primarily as it's a CI system, and they extend it to be a CD system. You can do this. What you end up with is systems that's got tons of stages, right, in your Jenkins workflow. The stages are very low level, and so it's kind of hard to reason about. It's kind of hard to change. All right? Spinnaker does CD, but sort of uses abstractions that are common or important for when you start thinking about continuous delivery, and I'll try to walk through some of those things. So from a continuous delivery standpoint, right, we really want this. We've got guiding principles. The first is to stage every change and verify production readiness as often as you can. That means systems and integration testing are done for every change, and you test in production realistic environments as much as you can. The second principle is automation, right? Where possible, automate everything or put everything together in some automated workflow. Even if there are manual steps, automate your delivery process, build your delivery process in some automated way. Automation increases confidence that your process is repeatable. Third, and this is especially important for production, right, is design your workflow so that rollouts and rollbacks don't yield downtime. Fourth is to maximize deployment predictability. Make sure you know what you're deploying and how your deployments are and should be behaving, right? No surprises here. Well, how do you achieve this? We sort of see four pieces, and I'm sure we could divide this up in any number of different ways, but first and foremost, what you deploy are immutable things, all right? Call them images, call them servers, call them containers. They're sort of hermetically sealed blobs that you use for deployment, not, something for which you've got some image or blob plus some configuration scripts, etc. Avoid configuration drift. When you're doing deployment, make sure that your deployments are tailored to the specific environments, right? If I'm doing testing, what I maybe care about, or deploying to a test environment, what I maybe care about is that my newest version of my microservice is up and running. All right, I maybe don't care about the old version, so I don't need to keep those around anymore. But for each environment, you've got environment-specific deployment steps. This is facilitated by deployment strategies. Everybody know what blue-green is? Who doesn't know what blue-green is? Okay, so blue-green is a deployment strategy whereby you have, let's say, a current version of your microservice running in production. You've got a new version you want to roll out. It's gone through all of your gate tests and so on and so forth. You roll the whole thing out, make sure that it's health checks, it's up and running, everything's fine, and then you sort of disable the old version. So I guess blue is the old version, green's the new. When the new version's rolled out, you disable the old one, but you keep it around in case you need to roll back. right? It facilitates very quick rollbacks, reduces risk. If there's any issue in production, you hit the rollback button, and immediately the blue servers, the old versions, come back up and run again. Now, some type of deployment strategies like blue-green, you're going, well, you know, I've got a limited number of machines in my on-prem solution. I can't actually do blue-green because I don't have enough capacity. This is where cloud comes in really handy, right? The elastic nature of the public cloud allows you to sort of get resources at will and hand them back at will. And shameless plug for Google Cloud Platform, right? We do by-the-minute pricing, so you're only going to pay for the resources you use, and that's really important. And now, in terms of predictability, right? As you're deploying, you want to incorporate deployment signals in all of your testing and feedback loops, right? All the signals coming in that helps with automation, that helps with reasoning about what's good and what isn't. So now, what's Spinnaker? It's a next-generation continuous delivery platform for the cloud. I didn't call it a system. I didn't call it a tool. The reason we call it a platform is because it's a foundation upon which we would love to get contributions from you and others in the community. How many of you know what Netflix, or know about the Netflix Asgard? A few. All right, so Netflix Asgard was a piece of software open sourced in 2012 for deploying services, microservices, to the cloud. All right, as Netflix sort of gained experience with their internal teams using Asgard, they said, well, everybody's now writing they're writing their own workflows, their own pipelines for delivery. And so Spinnaker says, I'm going to take the good parts of Asgard, which is the deployment, the ability to deploy, and I'm going to add to that continuous delivery pipeline blocks so that you can now define delivery workflows along with the deployments. The input to Spinnaker are build artifacts, like packages. The outputs are deployed images. All right, again, think of these immutable images, hermetically sealed containery type things. The pipelines, the term in Spinnaker, or pipelines form atomic workflows. They correspond to things like deployment stages. Hey, I'm doing testing, or promotion gates. Let's push this to production. You chain pipelines together to produce a continuous delivery workflow. What is it that you're deploying? The atomic unit of deployment, I'll talk about that next, in Spinnaker is called a server group. And I'll tell you more about it in a sec, so I'm not going to give it away anymore, what that is, or right at this point. What is important is Spinnaker is built on experience deploying industrial-scale applications to the cloud. So we know it works, we know it scales. It embodies key best practices, right, like immutable images, etc. We, Google, are looking at Spinnaker as something we can build on as we work on DevOps solutions with our customers, right? Hopefully, folks will choose GCP, but this is a multi-cloud solution, so you know what we really want to make sure is that you've got the right tooling and infrastructure in place and processes in place so that you can deliver software quickly and reliably. Right? I mentioned key features. It's open source and extensible. Find it on GitHub. Please, we welcome your contributions. What is here today is what's open source today is based on what Netflix needed, and we at Google sort of feel very similarly and believe in very many similar of the principles and practices. And so that's one of the reasons we're supporting it, but it's built so you can extend it. And I'll repeat again, right? I said multi-cloud hybrid before. It's a multi-cloud hybrid cloud platform technology, and so you're not locked in. All right, so now I'm going to walk through the workflow a little bit, just to illustrate as an example how this all sort of fits into things. Over on the left-hand side here, we've got, you know, sort of your typical git push, git commit thing. That hooks you into maybe a Jenkins CI workflow where you're doing build and test. The output is a package. Some piece of software you say, hey, look, it's been through my testing, my unit, and maybe light integration testing, that I think I want to sort of package up and deploy out to production. Replace this part of the diagram with your favorite CI development and CI system. And then Spinnaker kicks in. All right, step one is to take this package thing and bake it, turn it into an immutable image, a hermetically sealed entity. Then there are going to be a series of steps I call it deploy, where you're going to deploy to, let's say, a test environment, a QA environment, do some integration test. Maybe you'll deploy, there'll be another stage where you'll deploy to an environment where you're doing load testing or performance testing, right? There's a sequence of pushing out to different subsequent environments. And once you're done with one environment, all right, let's say it's test, maybe I'm going to disable or destroy the stuff that was running already before. I'm done, I can tear down the environment now. Or maybe I'm out in production and I can tear down the old versions because the new versions are working just fine. So that stuff in blue, that sort of produce the hermetically sealed entity, pushing all the way out through to production, is something that Spinnaker can handle in its workflows. And if you've got questions around, we can talk about containers and how that has some effect on all this stuff in just a little bit. But that's what Spinnaker does. And today, right, the top in blue, we can deploy to Google Compute Engine. We can build hermetic images for GCE. We can build hermetic images for Amazon Web Services. And deploy using abstractions, which I'll talk about in just a little bit. Work on containers is forthcoming, so if any of you are going to ask some more questions over the Q&A period. This kind of a process, I mentioned earlier, the reasons we're sort of excited and working with Netflix is it's very similar to processes we use internally at Google. All right? It promotes a model of building a candidate, testing it in a running system, and then pushing it to production. Now, let's go talk about, well, what the heck are we actually deploying? I mentioned the word server groups, or the phrase server groups before. The atomic unit of deployment in Spinnaker is a secure, load-balanced, fault-tolerant microservice. Called a server group, but think of it that way, right? So when you think about all those characteristics, all right, there's basic, then I need basic configuration settings like account information, regions, where's this stuff going to run? I need a load balancing, so I need some kind of load balancer specification. I want some kind of security at some level. What we're talking about here are really firewall rules type things. It's networking level security. And then I've got to talk about what kind of machines do I want? How much memory, how much disk, how many copies do I want, right? What kind of fault tolerance or redundancy do I want built in? So that's the server group, the atomic unit of deployment, a fault-tolerant, replicated, load-balanced, secure microservice. In Spinnaker, they have a higher level abstraction called a cluster, and that sort of addresses, it's a logical grouping of server groups where the grouping is based on versions of deployments, right? I've got version 1 or 17 deployed right now, 16 is disabled but there, as well as information that sort of spans regions and zones. I've got server groups deployed in 4 regions. That's the concept of a cluster. All right, and an application is a logical grouping of clusters. You could think of, Spinnaker itself is built on a number of microservices, and I'll talk about one of them a little bit. But the application Spinnaker itself, the whole composition of those microservices is an application. So that's the unit of deployment. What do you deploy? Well, what does it mean to deploy? It means to roll out images, right? Manage traffic cutover, roll back. And in Spinnaker, you could do that through deployment strategies, such as blue, green, canary, that are all pluggable. All right, there's one here mentioned Highlander. Does anybody know what a Highlander strategy is? You seen the movie? Yes. There can be only one. All right, so it's basically roll out a version. If it works, kill the other one. All right, that's deployment. Pipelines are now there to capture the workflow. And there's sort of 2 steps to the pipeline. One is the configuration piece that says, what am I supposed to do with this pipeline? Who am I supposed to tell? And then there are stages. So the configuration part of the pipeline are triggers. Hey, my Jenkins job completed. Hey, one of the pipelines in my continuous delivery workflow succeeded. I'd like to run. There's also a time-based one, right? Based on cron, you could sort of schedule the pipelines to run at any time you want. And we're working on now on adding just a simple webhook as a generic trigger for this thing. Parameters are things that you could pass to all stages of the workflow. Just think of it as metadata that you might need. And then there are notifications, right? We can send you email, SMS, HipChat, Slack. There are a number of ways of notifying users or notifying other systems as the pipelines progress. Stages are context-aware operations on the logical abstractions inside for continuous delivery. All right, the examples, and I've listed a bunch here, right? This bake, build that hermetic image. Deploy is deploying a server group, right? There are other server group constructs like disabling and resizing and destroying. Clusters, I mentioned, were logical groupings of server groups. When you sort of think of server group, you would think of, I'm deploying this redundant, replicated, fault-tolerant, secure microservice over here. A cluster says, well, I might have 7 of those. All right. Now we're starting to look at, so that sort of raises the abstraction a bit where you're kind of, well, you're thinking of server groups as globally deployed. And as a result, right, there's work ongoing now to sort of include cluster-level operations like resize cluster, destroy cluster, right? So you start thinking at a bigger, more global level. And then there are a bunch of other stages. What's cool, not only is this is open source, right? It's extensible and reusable. It's designed to be extendable by you. People can plug in their own pipelines, can build their own stages, can hook in their own triggers. I'll say we don't claim it's going to be terribly easy right now, but at least it's possible, right? And part of the objective of the Spinnaker team, both at Netflix and Google, is to make this easier for users to plug things in. So that's pipelines. You chain pipelines together to yield your continuous delivery workflow. And, in particular, you want to integrate with upstream CI systems, such as Jenkins. Okay? Now, how many of you folks are doing stuff that runs on Amazon or working with? Yes. So server groups in Spinnaker map to auto-scaling groups in Amazon Web Services. How many of you using Azure or working with? A few, that's great. So server groups map to resource groups. There's a mapping there. I know there are some people from Pivotal in the back. How many of you using Cloud Foundry? They don't even want to raise their hands. Okay, all right, we forced it. We forced it. So there's a mapping there. For Google Compute Engine, anybody using Google Compute Engine? All right, 1, 2. Okay, great, thank you. There's a mapping to manage the instance groups. So if you're familiar with that concept, then that's the mapping there. Anybody using Kubernetes or playing around with it? Okay, a slightly bigger group. Right, there's a mapping there. Today, the mapping of Spinnaker server groups is to Kubernetes replication controllers. I know we're sort of changing the model about how things are going to deploy. We'll see how that works in the future. But the point isn't to actually walk through the mapping, but to say that the server group concept, this idea of a fault-tolerant, secure, load-balanced, replicated microservice, is kind of common. It's agnostic to the cloud platform, all right? And that concept should apply to a whole pile of other things. If you want to add your own provider, another shameless plug for the openness, right, and extensibility, is Spinnaker's got a microservice called Cloud Driver. If you add and implement to the Cloud Driver API, you can have your own, you can bring your own cloud. Okay, Spinnaker was open sourced on middle of November of last year. We started working with the Netflix team, I would say, I think it was August 2014. And we said, hey, we'd like to work with you on something. You guys are like open source gurus, you're public cloud gurus. How about if we work with you on this Asgard thing? And they said, no. We've got something better coming, right? It's Spinnaker. But you're going to have to hurry up because we're going to open source in October of 2014. Right? It took a little longer to get all the pieces together. All right, but it's now out there. It's available on GitHub. It supports, out of the box today, full support, fully featured support for both Amazon and Google Cloud. Pivotal, right now, we're testing with government customers and getting feedback from other customers, so that one's almost ready. The Microsoft folks are feverishly working to get Azure support added. Soon it will support all that. Kubernetes will be coming soon. Another couple of months, I think we'll see something. It's in production use at Netflix. All right, 95% of their internal teams have switched over from their previous tooling to using Spinnaker. Active evaluation by the remaining folks there, and active evaluation by folks at Google and some of the other customers that we're talking with. So lots of interest here. Kind of neat. I mentioned it's available on GitHub. It's out there. Slack if you want interactive, some interaction with the team. People are there all the time. You could submit questions on Stack Overflow. There's also a public roadmap coming out soon, and hint, containers are a big part of it. You could try it out. If you happen to want to go to Google Cloud Launcher, we've got sort of a one-click get started with it. There are tutorials on Spinnaker.io and some tutorials on Google Cloud as well. There should be more coming. And please, we want you to contribute. So when Google open-sourced Kubernetes, we open-sourced it with our vision of what we thought the future of cluster management should look like, cluster management for the cloud should look like. Since then, it's been about a year, we really value the feedback that the community and the steering that the community has brought based on their needs, right? It's no longer Google's, it's the world's. All right, and this experience has been so valuable that we actively pursue open source work at Google, and not just Google building things and open sourcing it, but working with third-party open source software, right? There's an active project inside Google called Cloud Graphite, whose job is really to work with open source and make it work well for Google Cloud, reduce friction for moving there. All right, similarly, Spinnaker's open source did so with Netflix's vision, right, which I said a couple times, right? Google believes in that vision. We sort of practice that vision. We want the same kind of participation from the community with Spinnaker as we're seeing with Kubernetes. We want you all to drive this thing. All right. I would love to do a demo now. I'm going to sort of disconnect my screen a little bit. Things were broken about 10 minutes ago. And so I'm expecting we're going to be sort of a little bit in trouble. And if we are, unfortunately, I can't do the demo anymore. Oh, it looks like it's up. Yes, yes, yes. Okay. I'm going to plug this back in. And let's see if this is going to work now. Give me just a second. There we go. Yes. Okay, cool. So I'm going to go back to the front screen. So this is the home page for when you get to Spinnaker. That's all you see. A bunch of stuff. How many of you? I have to ask this question. How many of you are colorblind? The reason I ask is a couple days ago I was doing a little bit of a demo to a bunch of folks, and they said, "You just pointed to the red thing. Which one's red?" Turns out that 50% of males are colorblind. And so if you are, just let me know, and I'll tell you what shade of gray it should look like. So what you get is sort of a top-level view, right? We talked about applications. You can see that on the left. That was sort of this collection of microservices. Over on the right are these server group things, right? These atomic units of microservice-y things. Load balancers, security groups I mentioned when I talked about server groups a little bit. And then you see these search tabs, right? Infrastructure search, the little search bar up on the top. I only call out the search bar. It also shows up on all the other pages because, you know, for this, you actually don't really need search. But when you work at Netflix, it's kind of critical, all right? What shows up on the first page ends at __A. So without search, you can't really do very much. All right, I'm going to kind of dig in a little bit. CodeLab is this application that I made up. And I now want to talk about clusters and server groups. And I think I'm going to I'm trying to figure out which, well, both of them require me tripping over something. Okay, so I'm going to walk over to this side for this part of it. These rectangles, one says CodeLab Test, the other says CodeLab Prod. Think of those as clusters. All right, in CodeLab Test, we see this other thing that says V015, V15. That is a server group. All right. The little icon there says it's Google Compute, but it could equally be Amazon. And if we've got time and people are interested over the conference, I'm happy to show you this. This little green chiclet over there says there's one instance. It's a VM, a virtual machine image. One instance, the green says it's up and running. All right, so that's the bottom one. If we take a look at CodeLab Prod, we see there's a V014 that looks kind of similar. It's also got a green little chiclet. And then there's this shaded out V13 thingy. All right? The blue says that it's a blue-green deployment. I'm sitting there, I'm disabled, but I'm not forgotten. So if we're going to do rollbacks, it's going to be kind of important. All right? And if the names don't give you a hint, right, test is intended to be for a test cluster, prod is intended to be a production cluster. You can click on any of these things, and what you'll get is a ton of information. So I just clicked on the V014 over on the in the Code Lab prod, and then this whole thing showed up on the right-hand side. Tons of data. How did you launch it? What machines is it running on? What kind of replication do you have? What are your firewall rules? What kind of, where did you build it from? Where did the image come from? And there's access even to developer logs and so on and so forth. All right, so that's, clusters and server groups. And, there's similarly something for load balancers and similar something for security groups. I'm not going to walk through that. All right, what I wanted to do is take a few minutes and say, hey, look, we built a pipeline. I kind of want to walk you through this a little bit. We'll see how much time we have. Maybe I'll try to cut it short. But we've got a workflow, a continuous delivery workflow that's 3 pipelines. The first one takes a package, bakes an image, and deploys it to a test cluster. That's pipeline 1, bake and deploy to test. The second pipeline is validate test. It's where some test validation happens. And in this particular case, we're going to do it manually for the purpose of the demonstration. Once the new image has been, or the new image of the microservice, the new version of the microservice has been successfully validated, there's a promote to prod stage over at the bottom, which is I'm now going to take that image that was tested successfully and promote it to production. All right, the build is triggered by Jenkins. The bake and deploy to test is triggered by Jenkins, so let me just go sort of kick that off because that takes a while. And then I'll walk through. And then I'll walk through some of the pipeline stuff. So, I just mentioned to you what these things do, but what do they actually look like underneath the hood? So I mentioned all pipelines have a configuration stage, and then there are a configuration piece, and then a bunch of stages. This stage we call bake. All right, bake means bake an image. In this case, because my account supports multiple providers, you can see the provider here. It'll change to AWS if you wanted to. There's the package I want to bake, and I want to build it on a particular OS sort of base image. So that's the bake, the configuration part of the pipeline. Now, whoops, I'm sorry, I described this. I described the wrong thing. I described bake for you. My bad. So bake says, oh, come on. There we go. Okay. The configuration part for bake and deploy to test says trigger off a Jenkins job. It says type Jenkins, and then you point to the Jenkins server and you tell it which job it is. And so it says, I'm going to look for that completing to trigger off the next stage of my pipeline, which is bake. And I just walked through bake. All right, build a hermetic image. When bake succeeds, oh, look, there's pipelines 1. So I'm going to come back to this in a second. All right, you see some progress over here, right? This thing, there's a build. It used to be build 28. We're now doing build 29. Green says the bake succeeded. And you'll notice in this case, for those of you that can read all the way from the back, it says previously baked in parentheses. That means the image already existed, right? I just did a build on an existing package. Spinnaker recognizes that that package was already built and then looks up the corresponding image. Now it's going through the deploy step, which we're going to go and take a look at. Deploy says, I want to deploy this to, if you look towards the bottom of the screen, on Google into the Code Lab test cluster, strategy none, which says I don't care about anybody else, I just want to get deployed. All right, if you take a look in here, what you'll see is information about how to configure your server groups. All right, this says configure a cluster collection of server groups, right? You can see up at the top it says configure the load balancer piece, configure the security group piece, configure instance profile, right, machine type, disk, and all kinds of other things like that. So all of that stuff is available for you to trigger. When you click on any particular stage, you can actually take a look at the status and drill down in detail. So in this case, the deploy piece has succeeded. The deploy piece, we simply clicked deploy, right? We said deploy it over there, use that server group template for deploying, and under the hood, actually, a series of steps were performed to actually do that deploy. All right, and then there's the third part, which is destroy server group. And in this particular case, right, we're launching to a test cluster. When the new thing is done being launched, we want to tear down the old version of the microservice that was running in the test cluster. All right, we haven't done any testing yet, but we've gotten this far. All right? And so, you know, repeat, rinse and repeat. This will finish in just a second, and then that will trigger the validate test pipeline, which simply says, hey, look, I'm a pipeline. Basically, I trigger off the pipeline called bake and deploy to test, which was the previous thing. That's all you need to specify to get this pipeline running. All right, and in this particular case, the actual stage is a manual judgment stage, which means a human's going to come in and do some assessment of what's up. And there you go. Let's see where we are now. All right, so this is the yellow bit here. That's manual judgment. I'm simply going to, for the purposes of this demo, say yes, everything proceeded just fine in the test cluster. In the test cluster, that turns to green and then kicks off the promote to production pipeline. All right, promote to production has 2 steps. The first step is, whoops, here. There we go. The first thing is the promote to production is going to wait for the test the validation pipeline to finish. When that's done, notice I'm not doing a bake. There's something called find image. All right, and find image says go to find the image that was used in that test cluster and take that specific image and pull it over. You can specify here. Well, actually, I won't talk about that here. I'll talk about this under deploy. And then once I found it, I want to go deploy it. So same as before, I want to deploy on Google. I want to deploy to this particular cluster called CodeLab Prod. Strategy red-black. Does anybody know what red-black is? No? It's another name for blue-green. And Adrian, I'm going to ask you, is that because of the old colors of Netflix were red and black, or?
You just called it red-black before we had anyone else using blue-green.
Okay. I'm going to tell that story going forward, if that's okay. I always thought it was just blue-green, just with Netflix colors. We didn't know any better. Well, I like that you got there first. That sounds like a good story. Okay. All right, so at this point, the find image is done. We're now doing deploy. Blue says that there's, you know, things are underway. And as always, we can sort of talk about, you know, the series of steps and so on and so forth. So that's the pipeline stuff. I'm so happy the demo got to work. And that was the end of what I was going to show you, right? So Spinnaker is a continuous delivery tool for microservices in the cloud. Thank you.
So I have a first question.
First question, you have a list?
Yes. Yeah, I have several. So how does Spinnaker support network resources like multi-cause group, private networking in the cluster?
I'm sorry, can I ask you to repeat the question again?
Yeah, how does Spinnaker support network resources like setting new multicast group or private network for the new cluster?
So that's actually stuff that's being added right now. I can't speak to the internals at Netflix. But you know, things like subnetworks and VPCs and other things are actively being added. All right.
Okay. And the next question is, what is if the green cluster is partially broken and you found it after 1 day of collecting new data?
Yep. If the green cluster is broken and you found it after 1 day, so this is really cool. If we take a look at the clusters now, right? We've got new versions of stuff. Let's say the green cluster is broken. You can simply roll back. And that's it. And roll back, if you keep a set of versions of things, then you can specify the versions. But the intent with a blue-green strategy, right, is you keep the old versions around, some number of old versions around, so that it can be a one-click.
Yeah, but you would lose the data which already collected in the system, in the new environment, in the green one.
All right. I'm going to have to take that question offline because that's complicated.
Thanks.
Oh, there's a question over in the corner.
How you handle configuration of kind of like timeout for a load balancer, for example. So configuration parameters for your infrastructure?
Some of those I didn't show. There's some access to this stuff under the hood, right? So remember I pulled up, there was this menu and I said, here's where you configure server groups, and there's a whole pile of things. There are menu items that give you some level of configurability there, right? Including health checking and things like that. There are others where, you know, as we start to actually have people outside of Netflix use it and outside of Google use it, they're going, oh man, I wish I had this configurability. And we're adding stuff in, right? And the community's adding stuff in. Does that answer your question? Okay, cool. There's one there. There's one over there too.
Are you planning, this looks really nice and powerful. Do you also plan to have a kind of programmatic way to access it, or DSL, which describe it?
Great question. Great question. So, number one, Spinnaker is built on microservices, right? Itself is a microservice, multi-microservice application. What I have shown you, what I'm drawing all this from is one of the microservices called Deck. It's the UI microservice. It only interacts with Spinnaker through an API. All right, so you have access. There's another microservice called Gate, which is sort of the central way in. Each service, each microservice has a full-blown REST. You can access the services independently. Yes, you can do this all programmatically. All right, yep.
So there seems to be some overlap between Spinnaker and Kubernetes with respect to cluster management.
I was hoping
what are your plans to align this in the future?
I was hoping you would ask that question, because there are actually others. So Spinnaker and Kubernetes, right, is really the deploy side of the equation. There are similar questions about the bake and produce image side of the equation. All right, what's interesting here, right, is Spinnaker today offers two capabilities, two classes of capabilities. One is deploy to some environment. The other is construct a workflow, right, a delivery pipeline. For when you're deploying virtual machine images, right, the deploy step is some complicated sequence of steps inside Spinnaker. When we integrate containers, right, and our intention is it'll be containers running, right, deploy to Kubernetes. Kubernetes takes away some of that abstraction, so the state machines on the Spinnaker side for deployment get easier. You still need the delivery workflow. You're still going to want to use it for that. All right, and the interesting thing, too, is that if you say, look, today I'm deploying VM images, right? Tomorrow you want to deploy containers, right? All of the smarts are in here that you actually don't see the difference, right? From the user who's building up their workflow. They don't need to know that it's deploying to Kubernetes or not. Does that answer your question? Yeah, the abstractions will change, right? The abstractions on the deploy side will change. And Kubernetes is one example. Cloud Foundry is another example of a platform as a service, right? You want to build as much power into that platform as you can. The more power you build into the platform, the less power you need in Spinnaker, but you still need a way to sort of unify things. And while I'm at it, right, Kubernetes deploys containers, as do a number of other systems. Well, I talked about bake, right? Baking an image. Well, if you're already working with containers, what comes out of your CI part is a baked image. So you won't need the bake stage anymore. The stages will change a little bit. Cool. Any other questions? I'm so happy that demo worked.
So I think there is a lot of value in these configurations. So setting up a Spinnaker with a lot of configuration thing, and if you do something to the configuration, it will fail and so on. So is it possible to have this configuration of the deployment steps as code? So just as infrastructure as code, so do deployment as code?
Great question. So it turns out today, right, that of course all the pipeline, all the configuration information is stored inside Spinnaker, right, inside databases, right? Today, the way to set them up is through the UI, all right, although you can extract them as JSON and so on, but there's active ongoing work between Netflix and Google on creating .spinnaker files, right, where the configuration you pass it in with. And that's going to be, yeah, we're heading in that direction.
Can you talk a little bit about how Netflix and Google are working together and what that interaction's like. I mean, higher than this product, it's just interesting to see those two companies working together. And I'm interested in like comments on that experience.
Sure. So I'm going to say this. Working with the Netflix team has been fantastic. All right. I feel like I can't talk about, I don't know about any politics that got us to where we are, but I can say that we're joined at the hip as engineering teams. All right. We share with them freely, they share with us freely. Of course, we meet regularly, even though we're East Coast, they're West Coast, right, US. But I would say I feel like we're one engineering team, right? Google has, of course, its priorities, as does Netflix, all right? And what is important is that we understand each other's priorities so that when we're building features into Spinnaker, we're not doing something that's going to actively cause trouble for the other. Yeah, I guess, you know, if I can't tell the difference between working with Netflix and working with another Google team. It's that seamless. It's incredible. And it doesn't always work that way, right? I've worked with other companies before where we've done sort of partnerships. This one, I really feel like we're sort of mentally, spiritually, and everything aligned. And just last week, for example, we spent a week together, sort of fleshing out what the next 6 months are going to look like from our perspectives. Does that help a little bit? Okay, cool. No more questions? I guess everybody's interested in lunch, right? I wasn't going to make the lunch joke about me standing in the way of you and lunch, but... All right, I'm happy to talk more, and more importantly, right, Spinnaker is intended to be a community project. We want all of your engagement in this thing. We don't want Netflix and Google to be driving this. We want you to be doing that. Thank you.